welcome to the Rawkode Academy and today's episode of Rawkode Live. Today we are taking a look at Docker's BuildKit and buildx. Now before we do that, there's a little bit of housekeeping. First and foremost, please subscribe to the channel. Tick that bell and you will get notifications for all new episodes of Rawkode Live and Clustered and everything else in between. Also check out the membership options if you want to take advantage of some of the courses that we have coming out on the Academy. Currently, we are working through the complete guide to InfluxDB2. Also, we have a very active Discord server available at rawkode.chat. There's over 500 of us in there talking Docker, Cloud Native, Kubernetes, and everything in between. So come on, say hello, and I look forward to meeting you. Okay, today's session, BuildKit and buildx. I am joined by Tõnis Tiigi, a maintainer of BuildKit and an engineer at Docker. Hi there, Tõnis, how are you?
Hi, David. How are you?
I'm doing all right, thank you. Can you, just for anyone who is not familiar with you, although I'm sure they have all seen your GitHub avatar on every repository in the Docker ecosystem, but just tell us who you are and a little bit about you, please.
Yeah, so I work in Docker. I've been like a Docker maintainer for quite some long time. Did a bunch of different stuff there in the early days, like some storage stuff and containerd and even SwarmKit integrations. And in the last years, I've been like more looking at the build side. So I started with multi-stage builds. That's happened like a couple of years ago already, and then like kind of like bootstrapped the BuildKit project, and later on like the buildx project as well. And yeah, I guess that's where if you've seen my avatar, then these are probably the repositories there.
Awesome, thank you for that. So yeah. Multi-stage builds were just awesome. I think everybody was so excited with that. And then the BuildKit projects just seems to be bringing more and more functionality to what we need to build our images in an efficient and, super cached way. But for anyone who's not... Sorry, on you go.
Yeah, I hope they're going in the same direction. Like it's just like, I guess it takes a little bit time for like the mainstream places to catch up. So yeah, like at the moment, like like if I look at the Dockerfile talks or something like this, then like every talk is like multi-stage builds. So it's like, but like actually it's like happened like already like 3 years ago. So hopefully like in a year or two we will see like or BuildKit 12 like the same prominence.
Nice. Okay, so let's break down the two different components we're looking at today. We're going to be looking at something called BuildKit and something called buildx. Can we just explain what both of those are to the audience? Sure.
So of course, like Docker itself has always had like a build endpoint, right? So there's Docker build command. Everyone knows about it. It has been there for the beginning. So what BuildKit is basically like rethinking the background component of this from basically like ground up, and it's done in a separate project so that not only Docker can use it and we can like basically like rethink like what it means to have like a cool builder in like a modern container ages. And one thing for maybe not about BuildKit is that might be a little bit confusing is that if you're just like building images, you don't necessarily need to care about BuildKit itself that much. Like it's more like an internal tool. It's for like builder. If you're like building your own builders, if you're like developing a language and want to make sure that it builds fine in containers, if you want to like contribute to BuildKit and things like that, then you will look at BuildKit. If you're just building images, you're probably just using a tool that's using BuildKit under the hood, like Docker or like there's tons of other ones as well. So. Although like sometimes we like use BuildKit also as like an umbrella term to just like talk about like that's like a modern stack or something like this, but yeah, mostly it's like a backend component. It's very important for making all the builds efficient and all those things, not necessarily something that like a user actually needs to care about.
All right, awesome. And can we tell people what buildx is then?
So yeah, the buildx is more like a Docker side of a component where we we like where we develop our like Docker UI for the build. So this is where like the Docker user experience is. Like on BuildKit side, we're like very generic. We don't want to be opinionated or anything like this. We just want to provide a backend that like works for everyone, works for every use case. In buildx side, we're taking like the Docker user experience that that users know and just tries to like add new stuff on it, build on top of it. buildx itself is like a CLI plugin for Docker. So it comes with Docker. It's like a Docker command, but it's actually like a standalone binary. So we can develop it separately. And in addition to like just like a build command, there's also like a ton of other commands. Like I'm sure we'll get into there, but what's in there. But like buildx, when the old build command is just like one build command, then buildx is like 10 commands or something like that. So it provides lots of other use cases that weren't there initially.
Nice. Well, we will be playing with both of these in just a minute, so people will get to see them hands-on, which will be awesome. I think there's just one more thing I'd like to kind of talk about before we move into the hands-on component. And before I say that, if anyone has questions in the audience, please drop them into the chat. We'll keep an eye on it and we'll do our best to answer them as we go. Okay, so my final question. BuildKit. Like, I don't know if it's just me. I wonder if you feel the same from your side. But the adoption of BuildKit across other tooling seems to be, I think the velocity of that just seems to be going really fast. Like I see BuildKit being used as like a cache or a build layer for so many different projects, from like Dagger to Airflow. Is that something that you're seeing a lot of uptake on as well?
Sure, and well, like from my side, I'm glad that it's happening because that's what it was meant for. Like it's kind of like. There's definitely like when we're like doing any kind of build flows and like including containers in there, there's definitely like this shared part, that's common part that's actually very hard to develop, very hard to get right, and like and it doesn't make sense for like every tool out there to try to invent their own. Like that's how like even like the old Docker build, like it did something like just for their use case, like didn't quite think of it maybe true in the first version, and like ended up something that's like some cases worked for Docker, didn't really like allow further development, didn't work for anyone else. So like so yeah, that's what BuildKit is for. Like anytime you use some kind of like a container-esque build flow and you need caching support, you need to be fast. Like that. That's what you should be using.
Okay, thank you. All right, well, let's get my screen shared and try and work out what we're going to do today. So I've got the BuildKit repository here, the buildx repository here. I have a local directory with two projects that I'm familiar with, one in Go and one in Rust. And we have a shared VS Code live session so that we can both type as we try to explore this. So I believe what we're going to do is maybe start with the Go project, so blocks, and try and take a look at some of the new features that BuildKit exposes to make our build system cache efficient, using multi-stages and other things. I just try to explore some of these features that BuildKit brings to the table. Does that sound good?
Sure. Let's start with that one.
All right. So here's the fun bit. Oh, little thing. Currently, blocks doesn't build inside of a Docker file. We use Go Releaser, and let's change that. So we're going to attempt to build our Go application in a Docker file using multi-stage builds and take advantage of as much caching stuff as we can as possible. And I've heard a rumor, although I've not been able to try it yet, that we have the ability to pull binaries out and put them on the local machine and stuff. So we're going to try and explore this and get your knowledge and experience along the way as we go too.
Sure, sounds good. Yeah, like this kind of Docker file definitely is like the deadliest thing you can do in Docker files. Like if like anyone watching this learns one thing, then like don't like put binary or like copy binaries inside Docker file.
Yeah, we could definitely improve this. So let's do it.
Yeah. So yeah, like I assume like this one you call it from like a makefile, right? And you do like a local Go build and then and then you call Docker build after that. Or like if you look at.
Yeah, we've got a go build here. So not perfect, right? Let's get this into a container. So.
Yeah, and what's the other one? The other one was generating docs or something like that.
Yeah, we have a command that generates the documentation for us as well.
Maybe. Well, we'll see where we get to, but we can maybe do something for this one as well. Yeah.
All right, awesome. We got some love for buildx bake in the chat, so we'll take a look at that as we go, I'm sure. And we have a couple of questions already. I don't know if you want to tackle them now or not, but let's mention them, and then you can decide if we tackle them now or if we bring them in later. So Russell is asking, I'm hoping we can find out some juicy details. I've never heard juicy and Docker used together, but I like it, Russell. Something like cache being unprotected and a good target for injecting extras into images. Wahaha. I'm not sure I understand that question, Russell. Do you?
The last part, maybe not. I think we'll get to like the remote caching. Like we'll probably cover that as one as well. But first, I think we need to fix up this Docker file.
All right. Okay. Let's just do that first. You're right. We should. So let's pull up our. Why can't I see? There we go. So I'm assuming we're going to use a multi-stage build here, and maybe start with like a Go base image.
Yeah, I think we can like just put like a Golang something in here, right?
Yeah.
We can first do like a very simple one. So like that's also not good, but like to show that like it's not that hard, and basically do the same whatever build you had in here, right? I don't know. Was it something like this? Or?
Yeah, let me just, I think that was pretty much spot on for the command. I don't know if we do a go build command blocks, but I'll double check. Yeah, I'll just copy this.
CMD, okay.
Yeah, so we'll need. Okay. So in theory, this should actually give us the exact same thing, but without the local build step.
Yes. Well, you had Ubuntu in here. Like I just put Alpine because like I promote my stuff. But yeah, like that doesn't matter. Like it could be Ubuntu in here as well. And of course, like the benefit of this one is that whenever someone like checks out your repository, they don't need to have exact setup as you have, right? Like and they don't need to do this part of the build on the host and part of it in the container. Like everything is in a container. Like everything is defined by you as a project owner. You always get the same versions everywhere and things like that. Like you can even like just be nice in here and just make this configurable. Just I don't know if you use code 117 yet. Or...
yeah, well, it's like 116 minimum because we do use Go embed on this project. So 117 will be all right.
So yeah, like then even like in the end, if you want to, you could make like a test matrix, make this changeable and things like that, right? So, but of course, like what's bad about this one, right, is that your source code is still in here. You have the whole Go runtime in here, things like that. Like you don't want those, right? So yeah, like, let's make it multi-stage right away as well. Yeah, so.
All right.
It's something stupid can point it out. Yeah, and I think that should be enough for the first run, right? Do we want to try to build this? Or...
Yeah. Who would have is not to try it. So. Okay, I'm just going to give it. Sorry?
Yeah, we can just like maybe try buildx. So docker buildx build, or like let's first see what you have installed in here in this system.
Yeah, normally I would just do docker build. I'll give it a fake tag for now, and then pass in my context as dot. Like you're telling me we should evolve this now?
Well, we can let's try and see what it does. Okay, this one is a little bit messed up for some reason. It's just messed up for me. I can see that on the stream is correct. Like, in the live share, it's a little bit messed up. So yeah, like you can already see like the BuildKit UI, like that's a little bit different than what you had before. Something is wrong because we copied the root in here.
We got a comment about that just a second ago from Chris in the chat. So good eye, Chris.
And still not right. What did we do wrong? You don't need.
Yeah, that seems happier. There you go.
Okay. Yeah, yeah. So this should give me like a quite a smaller image, and you already see like the BuildKit UI in here. Let's cancel this one and let's look at buildx right away. Otherwise, we're going to like switch around a little bit. So what I can do in here as well, that there's a docker buildx command, hopefully in your machine. Yes, and it is. See what version this is. Okay, this is like a little bit older version, but I guess we don't care. Or do we want to update this?
I can do it. I did tell it to download the update earlier today, but I guess I didn't restart it. So when I do that, you want me to
actually, like I'm not sure if that's actually even there. Like if you want to update, we can get it just from GitHub, but I don't know it. Like we probably won't need anything from the new version anyway.
Okay.
Up to you. I don't know.
Well, let's see. Let's just continue, and then if we hit a wall with something because there's a feature that we're missing, we can talk about it, and then we'll do the upgrade.
Only thing that I can think of is that maybe if you get more error messages, then like the new version has nicer error messages. So what I want to show is in here as well that there's lots of commands in here, right? So there's a build command. Yeah, when I'm highlighting, of course, in my screen it doesn't show. But yeah, there's a build command that's pretty much the same command that you had there. That was the old docker build command. But there's a bunch of other stuff in there. Some people were asking about bake. Like you can see, bake is in here. There are options to create new builders in here that we'll probably get to if we get to the multi-platform things. And to manage those builders, manage build cache with disk usage and things like that. Maybe first thing we can do is just look at docker buildx inspect. That will just like show you what's the current like the builder that BuildKit is, or like the buildx is configured to use. So you can see that it's using the Docker driver. So basically, it's just using Docker like a regular Docker daemon at the moment to do the builds. And we have the platform support because like those come with Docker desktop. So potentially we can like target all those platforms. And then we can basically we can do the same command that you did before. What did you name it?
I just called it local. Yeah, a terrible name, but I'll do it. So what's different between my build command and this buildx build?
So what's different in here is not very much, because like by default, like buildx will try to give you like the exact same experience as you had before. So it was still like building with Docker daemon, so that everything you build will be in your Docker images and things like that. But what you get is these extra commands. So like once we develop, then there's going to be a point where like we have an option in here, or we have a command that's only in buildx, and you can't use the same one in the old command. So basically, just like if you stick to this flow, then you will go much further.
Okay. You got a hey Tõnis from Crazy Max. I don't know if you know anyone called Crazy Max, but there you go.
Yes, indeed, I know. Just look at those commands. Well, one more extra comment about this, like buildx versus Docker build, is that if you would run like this command, docker buildx install, then it will basically just like switch out your docker build command, and it like you can just try docker build and it will come to buildx. Okay. I don't know if you're ready to do this or not, but we can skip this for now. Like you can make your decision later.
Yeah, I mean, is the goal for buildx to replace build eventually? Sure. Yeah,
sure. All right, okay. Like it's. I think it makes sense for the user standpoint, right? Like sometimes you need sometimes you're using you're building with Docker. Sometimes buildx also supports like building like in Kubernetes or inside a container and things like that. Makes sense for the maintenance wise as well. Like we can develop build features without like waiting for like a whole Docker engine release and stuff like that.
Okay.
So but yeah, like your image was built like if we're yeah, I guess that's your command, right?
Yes, that is indeed the blocks command there. There you go. Perfect.
So how much time did it take? Do you remember? Like almost a minute or something like that, or like even maybe more. So
it took 52 seconds.
Let's try to make it faster, probably. One thing you can, I don't know if you noticed, if you run this command, or like maybe if you just make a simple change in here and just run it again. Is that it installed your dependencies in here, right?
Yes.
Like because you don't have a vendor directory.
Correct.
So yeah, like I'm in the vendor camp, but like, well, for sure, like it doesn't make sense. For example, that when you're building your process in your host, right, then you get all your caches and stuff like that. Like if you run, for example, make a code change like I did now and rebuild it, it doesn't take you a minute anymore, right? It only takes you a minute on the first time. So I think we can first figure out the dependencies thing, just to make this like this Docker file a little bit better.
You mean like we could copy in the go mod and the go sum first, run a go mod download, and then bring in the rest of the source?
Exactly, that's what I was thinking exactly. So we can just put the go mod in here and then run whatever it is, go mod downloader.
Yeah, go mod download I believe should be.
So benefit of this one, right, is that we only download the dependencies on the first time. As long as you don't modify your go mod file, then this step will always be cached, and it will. And next time you make a code change, only this one will run. It will already have dependencies. It will not start to pull them again. Right.
Okay, so let's build that and get the cache in place, and then we should be able to confirm that worked.
Sure. Do you want me to start this, or?
Yeah, I wasn't sure if you were still modifying the Docker file or not there.
Okay. Yeah.
All right, so that's doing the download.
So I guess in the meanwhile, can we already start for the next steps, or it's like
yeah, I have a question.
Yeah, go ahead.
I have a question that came in on Twitter from Kieran. Kieran asks, can I please ask Tõnis about how cache from and to are best used in a CI environment where different branches are all being built? So I think the question there is like, are the different builds from the different branches all using the same cache tag, or should you do something else?
Yeah, so yeah, I'm not sure like if other people will follow this question right away. It's very specific, but yeah, like my recommendation at the moment is to use the different cache tags for like give different tags for different branches so that they won't override each other. If you get to the cache from like there's like many different ways how you can actually like include the remote cache in your CI. Like in some cases, for example, if you're using like GitHub Actions, I don't think like the image cache is even like the best option. Like I think like there's like a local caches and we have some new GitHub caches there as well. Like that might be even like a better option there and might like solve this problem more elegantly. For example, like the GitHub caching, GitHub already provides you a scoping for different branches, so you don't even need to worry about this aspect at all. Okay. So yeah, like this one is now like yeah, it's fully cached, but like I can even make a change in here, right? In the Docker file, and if I build it again, then the half of the build was cached, right? So only like the binary is needed. Let's cancel this. Yeah. But of course, like the binary is still like binary itself takes too long time, right? Compared to your local one, because like the Go added some kind of like cool caching capability in the Go compiler, right? Like when you're running the Go compiler, it will put some files in some directory in your cache directory, and that's why your next builds are faster. So we can actually take leverage of this one in Dockerfile as well. So okay. For that one, so this is not in multi-stage anymore. So this is only in BuildKit now, but it's like every version of BuildKit. So run now allows a mount flag.
Oh. I guess Tõnis dropped. Oh, you're back.
Did I drop out there?
Yeah, I'm not sure what happened there. You just kind of disappeared.
But... Yeah, my whole like tab crashed for some reason. But yeah.
All right.
Okay. So
in BuildKit, you're saying we can use the -- mount tag, and then that's kind of where you dropped off.
Yeah. Okay. So maybe it's actually makes sense to look at the documentation first.
Yeah.
So that we see something. Let me point to the link. Should have a link now.
Yep. Got it.
So this one for this document lists like some like additional things we've added to Docker file. Like there's some cool things in here, like how you can do mounts, how you can do like secrets when you're cloning like private repositories, how to like forward your SSH. Recent version we added here docs, so this is like a document where you will find like all those described that are like the new Dockerfile additions. And one thing in here is that basically allows you to create mount points that are available when your process runs. So for example, like a bind, you can use just to like bind basically your build context to your process instead of making like a copy of it. Like the process can just directly see the files. In this case, like a interesting one is the cache one. So this one just makes like you can think of it as a volume basically. It's it gives you a directory. You can write into that directory. If you run the build again with the same cache mount, the files from a previous build will basically be there.
Uh-huh.
So you can use this as like a persistent anonymous storage where you can that you can use for storing stuff for the cache purposes. Of course, like this thing is like excluded from your instruction cache, so you need to be like careful about it, just to put things in there that your process can actually handle. Like basically, like you can put anything in there as long as your process still works with basically any content, because like cache volumes can be deleted in arbitrary times, and some other, like let's say you have another build and it writes the same cache volume, so you can only use it for certain things, but you can use it for the things, for example, when your compiler provides a cache directory, then you can just like use this as a location, and then your compiler will write it there, you run the builder next time, and it will get the files there as well.
Okay, that makes a lot of sense. And I can see there's a whole bunch of, there's also a temp file system, there's the secret stores.
Yes, exactly. Like for the secret one, for example, you can mount in secret files. So we make sure that they're like never stored in your image and stuff like that. And like on dempfs as well. And you can, the other one is you can mount the SSH sockets in there. So basically to like forward your SSH agent.
Awesome. So to correlate that back to kind of what we're doing then with this Go build here, is that we're doing a copy of the Go mod, the Go SAM, and a Go mod download. So that's just basic image caching, right? That's not using any mounts or local caching thingies.
Yes.
Now, is that okay there, or is that something where you would probably just encourage, to remove these two lines and then use a mount type cache and pull in the Go cache, or does it not matter?
Are you saying that like if we have a cache directory as well, then it doesn't really like give us anything to pull the dependencies before? But it actually still does, because actually like dependencies are not in there in the same location. So what we can actually do is we can put another cache mount in here. I think it's Go PKG, right? So for example, like next time this command runs, then it will pull the dependencies, but it will pull it on the cache mount.
Yeah, so do we even need to worry about the copy of the Go mod and Go SAM anymore? Like, is that actually bringing us any value, or is that just like the older way of doing things?
I guess, no, it's still like, in certain cases, it definitely brings us value, because the difference in here is that if your Go mod and Go SAM have not changed, then the builder will just skip over this command completely. Like otherwise, it will still run this command, and the Go itself will detect that it will need to compute some hashes of the files, and then eventually it will figure out that, hey, I already have those dependencies and stuff like that.
Okay, got it.
So like it will be faster, but it won't be zero, right?
Okay.
So it still makes sense to have them in dual level. In this case, though, like I guess theoretically, like these lines in here don't bias anything, because like this Go build will also write everything in the Go PKG when it's doing this first slow build, right?
Yeah.
So yeah, like I'm not sure like if you want to keep this or not.
I think it's questionable.
Yeah, one thing it might come back is if we get to the multi-platform things, then for example, let's say if we ever turn this into start to like cross-compile or anything like this to multiple platforms, then this step in here that's pulling dependencies, that is the same for all the platforms. Like if you're for example building for 3 platforms, this command theoretically can run once, while the compiler needs to run 3 times. So it might be like it might become useful there.
Yeah, good catch. Okay, so let's validate what you've just changed here. So we're now mounting in our cache here for the dependencies and the actual Go build cache. So what you're saying here is if we run this, we get a 52-second build, and then run it again. Is it even the Go build step should be near instant, right?
Yeah,
or at least faster.
It won't be instant. It should be like pretty much the same that you get on host. when you have all your like specific Go setup in your host, like everything is set up correctly, and you're like have those persistent folders in the host. One thing we could do an extra thing. I'm not sure. Like this copy probably was super fast in here. So again, I can see that it took like 0.2 seconds. So like I guess it doesn't much make sense to optimize it. But like you saw, there was a mount by bind there as well.
Yeah.
So basically, we could also do just like mount in here, and the bind is the default type. So if we do this, then we don't actually even need a copy. So then it will just mount our contacts into this working directory, and like we will not need to duplicate the data. We like by default it's read only as well. That might be an issue in some cases. I don't think it's issue in here, but basically that allows us to just directly access those files.
So does that mean
and avoid this?
So I might sound silly here, but I'm going to go on some of my things that I think I know about Docker, right? So when we do the build, we pass in the build context, which is a dot. And as far as I believe and I remember, this is literally a tar zip of the entire context to the BuildKit daemon. Can that actually be omitted now if we're using the type mount targets, or is that relative still to the build context?
So it's still relative to build context,
okay.
but so what you said was like half correct. So BuildKit does do like lots of optimizations. For example, like if we just like had a copy go mode in here and we didn't copy anything in our build, then BuildKit is smart enough. It doesn't tar everything up into giant tarball like the old builder did. It actually it pulls the files when you need them. So the builder side will tell you that, hey, I only need the Go mod, and it will basically just like fetch the Go mod.
Nice.
So and the same thing works with updates as well. Like basically like when you're doing a second build, the reason why like some of this is fast on the second time already is that BuildKit can already see that you uploaded the context one time, and the next time it just like does like a comparison and see what files are changed, and only copies the files that are changed. But it isn't directly like looking at your client disk though. Like we need to make a snapshot of the file. So like when it's asking that, for example, like give me Go mod, then we actually make a duplication on the daemon side of the file, because like otherwise, like if we like bad things would happen if we would allow this file to be mutable. So we need to make a snapshot of it. That's the only caveat. Like otherwise, it's quite smart. Yeah. So what did we get? What's the time of this one?
39 seconds for the build.
So it's 39 for the download and 39 for the
30.8 for the download and 39.4 for the build. Yeah.
Okay. So the next one, like if you would just want to build it again, should be like instantaneous, right? Because like nothing has changed. You can try this one for a second.
All right, let's do it. So we can just push up and run it.
Yeah.
All right.
Yeah. It was pretty fast, and all those, like it just needed to like validate that some tags are still valid, right? That your like Alpine has not updated and things like that. Your build context was uploaded in 100 milliseconds, but all the steps were cached, right? So now if you make some kind of a change, for example, like just like whatever.
Okay, so let's run this locally first and see how long it takes, and then we'll do the container build.
Sure.
Show blocks, command blocks and time. That running the local and then the container was just a question that we had from Russell, who wanted to see if we could compare the speeds. So I expect them to be pretty close. Maybe not as close as I thought.
Well, like in here, of course, it depends on what your like your state was before, and also like it depends on things like how many CPU cores you have enabled in Docker for Mac and stuff like that as well. But
yeah, there's
I don't know if I think by default we don't enable like your own machine or something like that. But
yeah, true. I can't remember what my configuration is. So.
It should be similar. So
that was fast, almost as fast as the host.
Yeah.
So yeah, you're right. That's awesome. And
I think it's well, yeah, it's similar. It's like I would have hoped it would be like a little bit closer. Like I don't know if it's like the CPU settings or something like that, or like it's
I'm on the default settings.
It's an Apple magic a little bit, but yeah, like it's.
But, I should get an M1. I'm sure that will help. But
yeah, for sure.
We went from 74 seconds down to 2.6, and then we were only 5.7 seconds here. But you're right that like my Docker for Mac does not have access to all my cores. It doesn't have access to all my memory. It's constrained. So, that's really close considering there are those constraints in place. So that's awesome.
The point is that like theoretically there shouldn't be much overhead. Like if at least like there shouldn't be overhead from like. From the standpoint of like that doing Git in container is less efficient because it can't access some files or something like that the host can access. So the process itself should be very similar, except of course like everyone gets this, like you just need Docker, you get the same flow all the time, and you don't need any like host setup or anything like that.
All right, awesome. We have a question from Noel in the chat who says with buildx it doesn't copy over the whole context. Only thing that needs to be copied. Does this mean that the Docker ignore is not needed when using buildx?
Pretty much yes. Unless you're doing like copy dot, of course, like that you shouldn't be doing. But like if you're just copying like the specific files that you need in Dockerfile anyway, then it already works as like a reverse Docker ignore. And also like you should never use Docker ignore for filtering your files anyway. Like you should, Docker ignore is same as Git ignore. Like you just put files there that are like that are like throwaway files that you never want to be as part of your project. Like if you want to like actually filter like some files from your project, then you use the copy rules for that.
All right, awesome. So there was another feature that we kind of spoke about briefly. Well, I mentioned briefly at the start, which was the ability to get a binary out of this so that I can access it and run it locally on my machine. Could we maybe walk through the process of doing that?
Sure. And it's very simple. If you maybe let's look at the docs first.
Yeah.
Like you should go to the buildx docs. So to do the buildx tab. And just scroll down a little bit where the documentation, you can just like write it from the README as well, yeah. So go to the build command in here, buildx build, and it should be the outputs. So dash this output, yeah, dash show. So this is just click on the link for the flag. Yeah. So the difference in it's like the conceptual difference between the old builder and BuildKit is that the old builder always built the Docker images. You always run, when you run Docker build, it will give you an image back. BuildKit does not do that. BuildKit just builds it, and it's left in your build cache. Like the user basically configures what do they want to do with the build result afterwards. So it might be that the build result is just left in the build cache, might be that it's turned into an image, might be that maybe you want to get a binary back, want to get a tarball back. There's like different options in here. So what you wanted is local binary, so it's the local option in here. And but yeah, you can see that there's other ones as well. You can get like a OCI tarball and things like that. But yeah, in your case, you just want the local one. So basically, you just want to do like -o and the directory where you want to write it. Like the first example, basically. Or like you probably want to write it to a bin directory or something like that.
Okay. So
but
yeah, I'll do it from the VS.
Write it, but don't press enter yet, because I'll then explain you why it's like a little bit wrong.
Okay, because I think what a lot of people do over the years, and I see this on Stack Overflow a lot, people asking questions, is that they use Docker to build their Go application, their Rust application, and then normally they run a container and copy the binary back onto the host. This removes that whole little hoop jump, right? So
absolutely, like the if you go back to the like the first Docker file you had where you copied that binary, right?
Mm-hmm.
Then like in the very old days where there was no multi-stage builds, then like how I built all my stuff, for example, was that I needed to have two Docker files. One was like this real one, and the other one was the one that copied the binary. And then I needed to do like actually you couldn't copy out from an image. You needed to create a container from an image and then copy the binary out from the container, and then you could use it in a second build. So like that's all gone with multi-stage builds, and in this case where you want to get just a builder in your host because you want to run it, like that's also like that's fixed by the show. So you don't need blocks in here. It's just like I guess you want like local bin directory at first, but the problem with this one now would be that it will copy out this whole stage, so it will copy out Alpine as well.
Can we copy out a single binary, or is it just?
Yeah, of course you can. So what you probably want to do in here is that you want to go from scratch. So scratch is like a nil object in Docker files, right?
Mm-hmm.
So it, like 0 layers, nothing. It's just nil. And we can just put the binary on the scratch. You can even like, so maybe a good pattern to do this is to name this stage binary, and then if we still by default we want to build Alpine or like images based on Alpine, so we have like a shell and stuff like that as well, then we can do from binary in here and in here. But so like we have a stage that is from scratch that only contains the binary, and then in the last stage we copy all the binaries. Let's copy them from bin. So the benefit of maybe this pattern is that let's say you have a second binary as well, like in whatever, like you're building 3 binaries or something like that. So you can put them all in here, and then you don't need to copy paste all the copy steps in here for like all the 3 copy steps for every binary. You can just copy like all the binary targets.
Okay, does that mean for our buildx command with the output flag that we've got pending, do we have to target the binary?
Yes.
Okay.
I mean, it depends on what we choose as the default target, right? Of course. Like if I would like put the binary stage as a last stage, or like just put like from binary in here, then you wouldn't need to do this. It just depends on you as a project author, like what you want like the default Docker build command to do.
Oh yeah, I think I dropped this in a make target anyway, right? So, but really I just want to be able to build that layer with the scratch and the bin and then pull that down to here. So does that command look okay to you?
Yeah, sure. Press.
Said with such confidence. Let's see. All right.
Okay, we were a little bit past it now, like 3.8. So
yeah,
so now, so and that, now you have the binary, right?
I built it for Linux, and now I'm trying to run it on a Mac. So there we go.
Exactly. We'll get to that as well, maybe.
Okay.
So
I like that.
But yeah, like this gave you the binary, right? So that you can. Right. So one thing is, of course, like if you want to like copy those binaries around, you probably don't want it to be dynamic.
Yeah, you want a static binary.
The actually like the recommendation I have for like all times you build Go is to just like not to always disable Seagull, but to always define what do you expect the Seagull value to be, because like especially if you get to like the building multi-platform targets, then Go has this weird logic that like your native target is using Seagull by default, and your other targets are not or other platforms are not using Seagull by default. So you get like a completely different like dependencies depending on what platform you're building. So I would just like always recommend you to just think about if your project is using Seagull or not. I'm not sure, is your project using Seagull?
No, I think it should be okay without Seagull.
Yeah, okay, then this is the simple thing to do. And that should take care of this one as well.
Okay, so shall we move on to, will we try and do multi-platform?
Sure.
Will I be able to build a Mac version in BuildKit?
We'll see.
All right.
If you don't run out of time, then yes.
So, oh yeah, because the Seagull enable has invalidated our build cache. So
that I'm not even sure like what does it do, like if it just invalidates all build cache, or it's just like because like all the packages have changed there. But yeah, like now it's
statically linked.
Like, yeah, now you can copy it to anywhere. So if we think about multi-platform now, then actually it's like by default it's very easy. So you had this command in here, right?
Mm-hmm.
And I'm not making any changes to the Docker file at all. Let's just look at help for a second. So there's a platforms flag in here, right?
Yep.
And you can just put like the basically the value of what platform you want. The value is the format of the value is like OS Arch and like optionally a variant in here.
Okay.
And the values are easy if you come from Go. Otherwise, like every component in the world defines their own OS and Arch values. So like you just need to look up what the values are. And theoretically, what you just need to do is just put like platform in here, and let's say you need ARM64, and basically you're done. And this actually works even without buildx. But with buildx, what you can also do is okay, my screen share doesn't handle this anymore because it went over some column limit. So basically, you can do like like you can just AMD64 in there as well. And like, how do we want to do this?
Can we do Darwin AMD64?
Not yet, because like remember when we looked at the Docker buildx inspect.
Oh yeah, it had the platforms in it.
It had like a bunch of platforms. Doesn't have Darwin in here, because so these are the emulation support that comes with, or like that comes with Docker desktop. So there's a machine, of course, supports one native architecture, but for the binaries, we can just run them through an emulator, but with a performance penalty. So maybe what we can do in here is just try to run this. You will get an error, and then I will explain the error. Exactly. So it would have worked if you just specified one platform, but because you specified multiple, then we can't use the Docker driver anymore, because like the whole like the Docker image store only handles images for a local platform. It doesn't handle multi-platform images like locally. So what you basically need to do is run buildx so that BuildKit runs in a different backend, and either like in Kubernetes or Docker container. So again, like if you want to maybe look at the docs first, or yeah, like basically you just do Docker buildx create use. So you can look at go one step back and look at the create command.
Right.
So back from the build command.
Oh yeah. Right.
Yeah. So yeah, you can grab the driver, for example. Like this one explains a little bit about the like what Okay, it's not explained here. Maybe like a little bit down there. So basically, it's 3 types of drivers that we support at the moment. There was a Docker container, Kubernetes, and the default that's just using your Docker daemon. So for the things like multi-platform images and actually for like some types of remote caching, like local remote cache and things like that, you want to use the backend that's either container or the Docker one. So, but otherwise, it's like you can just run the command, and I will like show you what it did in the backend. So you can that's it. So you can use the Docker buildx ls now. You don't have anything there yet. So now you will see that there's a new builder in here. It's in status inactive. The previously we were using the default builder with like the Docker driver. Now we're using the Docker container driver. So what you can do is Docker buildx inspect and just put -s bootstrap in there. That's you don't actually need to run this command to build stuff. You could just run build at the moment, but let's just show you how it comes up. So you go -s bootstrap. Yeah. So now we just like telling the builder that just boot itself. Don't build anything. Just boot itself.
Okay, so whenever we use the Docker container driver, we get a different container with BuildKit for the architecture that you want to build for.
Not for the architecture you want to build in, just one container that container now contains full BuildKit, so it has the full capabilities, for example, for the multi-platform stuff. So right. This one can manage the multi-platform images and things like that. So yeah, now you can see that it's running. You can run the ls again, for example. You can see that it still supports your platforms, right? And if you do the container ls or Docker ps, then you should see the container as well. Like yeah, like this is where the actual like the container is running. BuildKit is inside that container, and now when you run new builds, this is actually where your builds will happen.
Okay,
so now
we can run
the same build again with the 2 platforms.
Okay, so you do a lot of Go development, right? So, like, would you lean on BuildKit and multi-platform, or would you lean on Go as kind of cross-platform builds? Like, is there a difference there? Is there a preference?
What do you mean? Do you ask for like would I lean on like the Go's cross-compiling?
Yeah, would you use Go build with cross-compilation to different architectures, or do you think the BuildKit?
Absolutely, like all our projects use the cross-compilation, and I would show you like how to do this as well. But I just want to like show you like this is like the first way.
Okay.
Basically, to do this, remember, like we didn't make any changes to a Docker file, right? The Docker file was just like built for a single platform, and we only thing we basically say is like, yeah, like okay, like now give me an image for a different platform, or give me a multi-platform image, and it does work out of the box. So at the moment you can see, for example, that yeah, it's running the it's running the go build command at the moment, and you can see that it's actually running 2 times, right?
Yep.
So one is running natively like you did before. You don't get previous cache at the moment for this build because you're in a container now. So you will get the go cache again for the next one, because you switched the backend, then you lost that cache.
Yeah, that makes sense.
So this is so this variant is super simple, right? No changes. Obviously, like one of them is running in an emulator, so it has a performance penalty. And I would say
the ARM64 one's going to take a little bit longer than the AMD64.
Yes. Like I would maybe expecting here maybe like 3-4 times longer.
Oh right.
So especially like it depends on what your Docker file is doing. So if you're like installing packages, like for example, you're from Alpine installing packages, absolutely no problem to run this in an emulator. It will take like 100 milliseconds natively, and it will take like 150 in an emulator. Like there's There's no CPU intensive things in there. Like it's absolutely fine to run this in an emulator. Like if you're doing compilation of like big code bases, then you will really see like where this emulator thing will start to like hurt you. But still, like given that it didn't require any changes in the Docker file, like you will not build this like every time you make a code change, right? Every time you make a code change, you will build the previous one that we had like running like in 3 seconds or something like that.
Mm-hmm.
Like if this runs like one time in your CI, like maybe it's even fine. Like I would say like we don't use this one. I will next show you like what we use, but I think most people who use buildx today use this one because like the like multi-platform build, it runs in a CI. Yeah, it takes like 3 times longer. It doesn't slow them down at all. Those builds don't happen that often.
Okay. I guess we've got about another minute before this one.
I hope this finishes. Maybe if you go back to the browser, I can talk a little bit about. So you got this for free because you're using Docker Desktop, right?
Yes.
So what that means is that when in your Docker Desktop VM, you already have the emulators installed in the kernel, basically of the VM. So every time we make that we make a builder, it's just like you can see that hey, it supports 6 platforms. Why it supports 6 platforms is because they're already like the emulators are loaded in the kernel. If you're not in the same system, then you actually need to do one more step. I'm copying you the link. You need to actually load the emulators. So if you go to that link, you can actually see like how you would set up those emulators if you don't have them in the system. And it's very simple. It's just a Docker image. So if you scroll down a bit, basically you just run the install command in there, and you can just say let's just install all, and then it will load all those emulators from this image to your kernel, and you have the same experience every time. So for example, like in the CI system or something like this, maybe you want to run this beforehand to make sure that that you have those emulators ready, and then it will show you what's all supported by your system and what emulators you have installed.
Okay, so basically it's just using QEMU then, and you can just install your own platforms if required into the BuildKit container using this tool.
And no, this is the QEMU. So this is like the QEMU needs to be in kernel, then BuildKit can use it.
Right. Okay.
So basically, like once you install this command, it will install the emulate. It will enable QEMU basically in your kernel, and then when you do like buildx inspector, buildx ls, you will see that BuildKit finds all those emulators for you.
Right. Okay, that makes sense. Nice.
Okay, did our build figure it out or not?
It's still thinking. But why don't we? I mean, there were a few subcommands here, right? And we've not covered all of them. Maybe we could. What does the bake subcommand do?
So bake. What bake does is like, for example, like when the command you're running at the moment, right? Like the binary, you're running a command that's doing a build. It sets a target to binary. It sets the output to local. It sets the platforms to do platforms, right? And you need to remember it somewhere. Like you need to like put it in a makefile or something like that. So what bake is that it allows you to create these high-level targets that already like contain your specific configuration. Like for example, like you can say that binary target for my project means that I'm building a binary target. I'm putting in a -10 pin format. I'm building it for 2 platforms. You can write this all in a bake file, and then you can run a Docker buildx bake binary, and it will be all taken care of. It's like, it feels like a little bit like make, right?
Yeah.
Like that's where the name comes from, right? But it can do like things that make can't do, right? Because like in make you will need to, if you're building like multiple targets, for example, like make can't figure out that those targets can actually build in parallel and stuff like that. That buildx can figure out. If you just go back to the bin format project, I believe bin format project uses bake.
Yeah, there was a
and bake, like this is HCL. Like it doesn't need to be HCL. Like it can be just a compose file, or even like the language is a little bit like not that important in here. But yeah, you can see like we have some like nice, yeah, exactly like that. The binaries thing is exactly like explained here in here. So in this project, you could basically just do big binaries, and it will figure out what to do. And we have some like weirder targets in here, like some on my project have like the linters, and like for example, you have the docs generation and the vendor generation. Like they can all be like defined as like big targets, and then in the end you can have like a group that just say like pre-commit or something like that, and that just like runs all of them in parallel, all the validation logic in parallel. Like this one is a little bit complicated because like there's like multiple variants of it, and like so there's like we have like a bunch of configuration options that go like build different versions of those emulators and stuff like that. So, but that's basically it. So finally, 450 seconds.
yes.
So
took a bit of time, but we got there.
To prove the point that if you're running a big compilation step, then maybe emulators is not the way to go, unless you're running like the build once a day, like then whatever.
But are those both cached now?
Yes.
Okay.
So first of all, like you can look at their bin directory now, and you have multiple binaries there.
Oh yeah, look at that.
So yeah, so you should have the ARM64 binary. You can just like test it with the file, just show that it's
the typing, but yeah, we'll get there.
Yeah, so ARM64.
Very cool. So I could just copy that target like I did there and create a docker-bake.html and then just run docker bake target, and that should still all be cached and just does the exact same command that we ran.
Absolutely.
All right. I want to see it.
Okay.
So, you said there were multiple formats. So HCL is one format, and there's Docker Compose.
At the moment, we can if you have just like a compose file, you can just do like a bake with a compose target as well.
Okay, let me replicate this. Copilot's too good. There we go. And we want to target the binary target in our container, and output is bin. So I think that's the same defined in HCL as we have in the command line. Is that?
Yeah, that's pretty much it. So you can also do.
So I'm not. Oh, the target is. No, wait, that's the tag is local target. Yeah, okay, that's the same, I think.
You can also do group default.
Yeah, I seen that in your file. So why don't I just?
Yeah. Yeah, exactly. Yeah. So.
Just match this. So with this, instead of that big long Docker buildx, we can do buildx bake.
First of all, you can do like a bake. That's just print, for example, for just like a test. This will show you like what is going to be built.
Sorry, dash test.
Print.
Sorry.
Yeah. What's wrong? What's the name of the file?
Docker-bake.hc.
Oh
no, I've got it in the wrong.
You got it in the wrong directory, I think. Yeah.
There we go.
So yeah, now it will show you exactly what it's going to build, and yeah, like if you remove print, then it will just run the build for you. And you can, of course, like the command line takes the targets as arguments, so you can do like binary, foo, bar, and like everything. Like you can do like million targets together as well.
Okay, so it used the build cache on our AMD 64. Hopefully, the ARM 64 is just going to be about 30 seconds.
You should still have cache, like Go cache should still be there.
There we go.
So, okay. Didn't take that long. So it took
All right.
3 times as long as the native one.
Okay, I like that bake file and just making it all declarative and getting it like, yeah, I could write a make target, but maybe just
you can do like in the HCL syntax you can do like weirdnesses like define variables and like functions, and like you can like a little bit like have like a macro style in there to have it like more configurable as well. Like this is like a project level logic you would maybe put in a bake file that like defines like this is like a different configurations of how your project is supposed to be built and stuff like that. In Docker file, maybe you have like more generic things like Go version and stuff like that are like universal for all the projects.
Yeah, we got a comment from Crazy Max talking about some of the things that they're doing with Bake. So build in binaries, multi-platform image, generate docs, lints, update, validate vendors, generate probus, and test the app, all in a Bake definition. Sounds pretty cool. If you've got a link, Crazy Max, to one of your projects that does that, I'd love to see the HCL at some point. So please share. And Noel with a comment saying that they love conditionals in Bake. So cool. Lots of options there. All right, we've covered an awful lot here. Is there anything that we've missed before we finish up that you think would be really cool to share with people? Put you on the spot. Like, what have we forgotten?
I mean, what we've forgotten is the cross compilation. I'm not sure if we can push through it with 10 minutes or not. Like that's what was for your question of like what's the alternative for QEMU and what's the how you can get a Darwin target. Like we can try to answer that if we can push through it.
Well, yeah, why don't we make a start on it, and if we feel that we're not going to get through it in time, we'll, we can leave it. If we're almost there, we can always run a little bit over. We can see, or if you want, we can leave it for another day. I'll leave the decision in your hands, Tõnis.
Okay, yeah, let's try it.
Okay, so that's good.
So what we want to do in cross compilation is, if you look at this our Docker file again. Maybe I'll post you a link just again. So the link I posted you is how I do cross compilation and how like Docker projects do the cross compilation. So that one is like a little bit advanced. We will probably not go to this one, but this one has like a first section. It has like an introduction to cross compilation. So yeah, like this cross compilation primer. So basically, the best way to do this is that we have this certain automatic arguments in Docker files that we just provide from the builder. Like you can even click on the link, the automatic platform args in global scope. Yeah, so this is the Docker documentation. So basically, all those arguments are available to you automatically inside the Docker file. We just define the arg, and we will figure out what the correct value is. So basically, if you're building for like a PowerPC, for example, we will put target platform equals PowerPC, target OS equals Linux, Arch equals PowerPC.
Okay.
And then you can use this one in your Docker file to have like some stages be native to your current platform, some stages to be individual for your target platform, right? So if you go back so the easiest way to do this in a cross compilation thing is that in this first stage we say that there's a massive mistake in this example. It's not supposed to be from -- from. It's supposed to be from -- platform.
There you go.
So
pull request welcome.
Yeah. So it's from and you say that this stage is always for the build platform. So you say platform equals build platform, and then this stage will always be the same. Even if you build for ARM and you build for AMD, it will always be AMD in your case, because I believe you were an x86 machine, right?
Mm-hmm. Yep.
So it will always be the same. It will always be the same command. And then when you define the target platform, now the compile step is different because the target platform value is different. So the Alpine image was built one time, and then compiles command ran two times with a different argument to the dash target. And so now we have two binaries, and now we have the second stage, Alpine, that doesn't have any dash platform flag. So now this stage is separate again for every platform, and we're just copying the binary to that stage.
Okay.
Make a little bit sense.
Yeah, I think that made sense. Yeah.
So basically, in your case, like I switch back to the code now.
Okay, so you're adding the from platform to our first part.
Yeah. So basically, like in here, you could, like, if you're stupid, then you can write something like this. Like, but like, let's not do that, right? It would be the same value, but like this one, then you can cross compile from ARM as well. So, and in this case, like dependencies, we can only pull one time as well. Like we don't care about pulling them twice, right?
Mm-hmm.
And now in here, we can just do target OS, target arch. So just to define those arguments so that they're now available. And of course, like Go supports cross-compilation super easily.
Yeah.
So we can just do target OS in here. Go arch equals target arch. And I think that's it.
Okay.
Let's try.
All right. So
you can just run the same pay command again.
Yeah, just nothing changes. That's it. All right.
Yeah. Now you can already see like the Go image only one time in here. Previously it was multiple times. And now you understand why the one is cached, right? The other one isn't, because like your AMD64 node did not have the ARM cache yet.
Okay.
Right. Okay, it makes a little bit sense. But now, like if you run this, if you make a code change now, and you run this again.
Okay. So
6 seconds in total, like that's okay, 3 for each binary. So now you have you're building for multiple platforms with the same speed that you had before.
yeah, so there was a change there. It only happened in a Docker file, and I want to make sure I understand this correctly.
Sure.
Right?
Yeah.
It's previously, before we added the platform to the from here and the args with the target OS, we were using different container images with QEMU emulation to compile the things within the different containers. But Docker or BuildKit seems to be smart enough to work out that if I have a platform from with these arg things here, that it can do that same compilation in the same container. So it's no longer using the second QEMU in the BuildKit. Is that right?
So the first thing you understand in here is that the whole like the BuildKit design is like a deduplication, right? So you're building like two targets in parallel. They share some parts. Like BuildKit will just like optimize them together. Like it's like it's one of the like the key principles of the design. So like to be efficient, the first step is to not run the code that's useless, right? So it will always detect those things that if your two builds share some components, then it will combine them together. Now in this case, for example, let's say you're building for the ARM target. Like this stage started before there was the dash platform flag in here. Those commands would have been different. One of those commands would have been get me a Golang image for AMD64, and the other one would have been get me a Golang image for ARM64.
Yeah.
Now, because they're both fixed to the build platform, now they're both saying, give me a Golang image for AMD64. And BuildKit will instantly like notice that like, hey, like those two builds they're using the same image, so they're the same command. and then it just like, for example, runs the go mod download in here. It still understands that those two commands are the same command that runs on top of same image, so they're the same.
Yes,
But
it's
the compilation
now.
step,
Yeah.
but the compilation step is not same, right? Because the compilation step has those two different environment variables, so that command is not equal anymore.
Okay, so I'm just going to make this visual for other people in case, because it took a little bit moment for me. But when these were emitted, what we actually had were multiple steps like this. However, when you made that change to say use the build platform, we actually reduced the instruction set that was sent to BuildKit, which is why it can do those jobs as it did. Okay, that makes a lot of sense now. I got it.
So yeah, like let's say like if you were building this Alpine target in here, like in line 17 still, like then previously we would have pulled 2 Golang images and 2 Alpine images, right? Now with this change, we're pulling 1 Golang image only. We run the compiler always on 1 Golang image, but we still have 2 Alpine images, right? Because in the end, like we want to push the EM64 image based on EM64 Alpine, and like the busy box in that image will come from different images.
Got it. Very nice. I like that. And we did it in time, right?
Yeah. So one thing that was different first of all, let's check your Darwin. So just run the same command, but put your Dashes platform, put Darwin EM64 there. Because now there's no reason for the Darwin not to work.
Sorry, can you say that again? I missed it.
In the Dashes platform, you can.
So in HDL.
Like, yeah. In here.
You want to add the Darwin.
Yeah. Yeah, you can even like remove the other ones because like I guess for the default, like you just want your local one, right? Yeah, you can just try this one.
Oh, okay. Okay, so this, this works because of the build platform on the from line, which always pulls the AMD64 or whatever my build platform is, and then relies on the Go cross-compilation by setting the target OS and the target arch, which is what I got it.
You understand why it didn't work before, right?
Yes.
Because like a first step, like it doesn't even reach to QEMU. It's like the builder would say, like, give me a Darwin AMD64 image for Golang. And of course, there's no such thing. Like there's no Darwin image there. Like that's why it doesn't work.
Finally, yeah. I'm obviously just picking this up a little bit slow, but I got it. That's awesome. So now for languages like Go and Rust, where cross-compilation is available with the compiler toolchain, you can really build some pretty nice build pipelines with Bake and HCL and BuildKit. I think that works really well. Cool.
Yeah, and so now you can try to run this one. Like this one, just bin blocks should run in your machine, right?
Well,
yeah, the same command.
Oh, so
no,
it's not.
It's this one because you only built a single platform. It's configurable actually. Like if you want it, yeah, it works. And awesome. The last thing.
Yeah.
What was the like? If you remember, in my project, there wasn't Darwin AIM64 in there. There was just local. So local is just like a hack thing in the bin format project where you copy the bake file. Yeah, that one. Like I had local in here.
So anyone that wants to build the binary, they can just use that local.
So local is just like a magic platform value that is like if I'm running your bake file, I'm on ARM. Then it will mean Darwin ARM64 for me. If like a Linux person is running Bake on their machine, it will mean whatever like their system is. So if you want to just local binary, then you would use this one instead of hard coding Darwin AMD64. It will be exactly the same binary in the end.
Okay, so I can just local.
Yeah, exactly.
I guess that's all. Couple back, and that should be pretty instant, right?
And if you want to get like further into this, then this project, this XX project, is like what I use like for more complicated cross-compilation flows. Like for example, you can imagine like at the moment we have the CGO enabled equals 0 in your build, right? Like let's say you need CGO enabled equals 1, then it's not so simple to do cross-compilation anymore, right? So because like the C cross-compilation toolchain is way harder than Go cross-compilation toolchain, and this project basically makes it easy. So like anyone interested, like you can look at, just follow the examples in here. Like there's examples in here how to build C, and once you set up C, then you automatically have CGO and things like that.
So is that
and like how to install packages, and like you can like basically like I hope like for most like C and Go projects, like this basically is like almost like a drop-in. So we just like drop this into your build stage, and basically the same simple things that you had in Go, like this works for the different languages as well.
Awesome. All right, I'll include a link to this. I think people should check it out to see some of this. So there's the Go example there. So
yeah.
All right, cool.
So this is what we actually use in all our projects. We just like drop this into our Docker file, and then we have those million exported targets. Like if you look at like buildx itself, like it's all built from Docker file. It's built into like, I don't know, 10 platforms or something like that, and it's all through this.
Nice, very, very cool. All right. Anything else? Are you happy with that? Like,
sure.
Yes.
The question. Big supports Compose. Yes, it does support Compose.
Yeah. So Kieran's question: it would be cool if it could support Compose spec YAML. Is that different from Docker Compose?
No, it's just like you can use like if you have a Compose file, you can of course build it with Compose itself as well. You can also just directly build it with buildx bake. You can just do basically like if you do buildx bake, you have a Compose file in a directory. It will just build all your Compose services with bake in parallel and everything, all the goodnesses with that one. Or you can like choose a Compose service from your Compose file, same as you had your binary target in here.
Right. And we got a question from Noel asking, does XX use bin format magic?
So no, bin format is the QEMU emulation, right? Bin format is actually like the bin format MISC is like the kernel feature that allows loading the emulators. That's why it's called bin format. So bin format is the emulation side. If you want to add emulation, if you take the performance penalty but want no changes in your Docker file, X is cross-compilation. So that's for defining the if you're going to the cross-compilation route, then XX makes it easy to build C projects and CMake and all those things.
All right, awesome. I don't think we have any more questions. I have learned an absolute metric ton today looking at BuildKit and buildx. So thank you for walking us through this, Tõnis. Really, really cool projects. I'm looking forward to adopting more Docker files that aren't just copying in a binary. I think we've cleaned up. I think we've cleaned up the Qblocks project really nicely. I'm looking forward to sending that PR to Brian and getting him to take a look at it. So very, very cool. Yeah, there's a couple of thanks coming in the chat, but I'll throw them up in the intro. Tõnis, thank you so much. It's fantastic. So thank you for spending your afternoon with us.
Thank you.
All right, have a great day. Bye all.
Thank you for watching Rawkode Live.